today we're going to review what we've talked about this whole week. So we're going to review absolute value. Remember, absolute value represents a positive. So if you have the absolute value of -6, it's going to simplify into a +6. When you have absolute value equations and it equals a number, you're going to make two equations. One equaling the positive number, one equaling the negative number, if that number is positive to begin with. Now, if your absolute value equation equals a negative number, it's going to be no solution. If you have absolute value equations with variables on both sides of your equal sign, then you're still going to make two equations, one where the expression is positive, one where the expression is negative, and you're going to solve both of them. And after you have your two solutions, you need to plug them back in to the original problem and verify if you have a true statement or a false statement. When you have variables on both sides, it is possible to have two answers, or it's possible to just have one solution if one of your solutions turns out to be false and one of your solutions turns out to be true, or it's possible to have no solution if both of them are false. So now let's talk about absolute value inequalities. In an absolute value inequality, you also have to isolate the absolute value. If you have a less than statement, you have an and statement. If you have a greater than statement, you have an or statement. If you have an and statement on your number line, you would shade the middle portion. In an or statement, you would shade the outside portion. If your absolute value inequality has an inequality to a negative number, then your answer is either going to be all real numbers or no solution. If your absolute value is less than a negative number, well, that would be no solution. If your absolute value is greater than a negative number, that would be all real numbers. So, those are all the topics we've covered this week. So what we're going to do now is we're going to look at 3 examples that review everything we've done this week. Okay, so here we have our first example. 2 times the absolute value of 3x minus 9 minus 10 equals 20. So we need to isolate this absolute value. So we're going to add 10 to both sides here, eliminating the 10. And we get 2 times the absolute value of 3x minus 9 equals 30. Now we're going to divide both sides by 2, reducing the 2, and we get the absolute value of 3x minus 9 equals 15. It equals a positive number, so it is not no solution. So we need to make 2 equations. 3x minus 9 equals 15, or 3x minus 9 equals negative 15. We're going to add 9 to both sides to solve, and we get 3x equals 24. Dividing by 3 gives us x is equal to 8. On the other equation, we're also going to add 9 to both sides to solve, and we get 3x is equal to negative 6. Dividing by 3 to solve, we get x equals negative 2. Now, since this equals a number, we don't necessarily need to check our solutions. X equals 8 and x equals negative 2 are perfectly legitimate solutions, and we can stop right there and say we solved. Okay, here I have example 2. Example 2 is the absolute value of 2x minus 6 plus 3x equals 4x plus 12. I need to isolate the absolute value, so we need to subtract 3x from both sides. Eliminating the 3x, we get the absolute value of 2x minus 6 is equal to 4x minus 3x. That's going to be x plus 12. So now my absolute value is isolated. I have an expression on the other side. We can make 2 equations. 2x minus 6 equals x plus 12, or 2x minus 6 equals a negative. And we're going to open a parentheses and say x plus 12 here. So now we're going to solve. We're going to add 6 to both sides here, eliminating the 6. And we get 2x equals x plus 18. Now we're going to subtract x from both sides, eliminating the x. And we get x equals 18. On the other side, we're going to distribute the negative to both sides here, to both terms here, sorry. We're going to distribute the expression to x and to 12. So we get 2x minus 6 equals negative x minus 12. So now we're going to add 6 to both sides, eliminating the 6, and we get 2x equals negative x minus 6. Now we're going to add x to both sides, and we get 3x equals negative 6. Dividing by 3 gives us x is equal to negative 2. So now we have our two solutions, but we can't say these are our solutions yet. Remember, there's an x or a variable on both sides of the equal symbol. So we need to check our solutions. So we're going to plug 18 into our original problem. So we're going to say the absolute value of 2 times 18 minus 6 plus 3 times 18 equals 4 times 18 plus 12. And let me put a line down the middle here so that it's easier to see that there's a difference there. Okay, so now we're going to simplify. At the beginning, I have the absolute value of 2 times 18 minus 6. 2 times 18 is going to be 36. Bring down the minus 6. Close the absolute value. Plus 3 times 18 is 54. Equals 4 times 18 is 72. Plus 12. Now we're going to go back to the beginning. 36 minus 6 is 30. So we have the absolute value of 30. Plus 54 equals 72 plus 12 is 84. So now back at the beginning, the absolute value of 30 is just 30. So we're going to say 30 plus 54 equals 84. 30 plus 54 is 84, which equals 84, which is true. Now, since it's true, that means that x equals 18 is a solution. So we can box it. That is correct solution. So now we need to check negative 2. So we're going to plug negative 2 into our original statement. So we're going to say the absolute value of 2x minus 6. Sorry, I did that wrong. Let me back up here. The absolute value of 2, and x is negative 2, so times negative 2 minus 6, close the absolute value, plus 3, x is negative 2, so we're going to plug in negative 2, equals 4, x is negative 2, so we're going to plug in negative 2, plus 12. Okay? And now we're going to simplify this. So at the beginning, we have the absolute value of 2 times negative 2 minus 6. 2 times negative 2 is negative 4, so we're going to say the absolute value of negative 4 minus 6. Close the absolute value. And then right out here, I have 3 times negative 2. 3 times negative 2 is the negative 6, so we're going to say minus 6 equals 4 times negative 2. Well, that's going to be negative 8. Bring down the plus 12. And now we go back to the beginning. Inside the absolute value, I have negative 4 minus 6, which is negative 10. So we're going to say the absolute value of negative 10 minus 6 equals negative 8 plus 12 is 4. So now we go back to the beginning. The absolute value of negative 10 is positive 10. Bring down the minus 6 equals 4. Going back to the beginning, 10 minus 6 is 4 equals 4, which is true, which means x equals negative 2 is a solution. If one of these were true, and one of these were false, we would only have one solution. But because both of them are true, we have two solutions. If both of them were false, we would have no solution. And this is example 2. Okay, so for example 3, we have an absolute value inequality. Notice my absolute value is not isolated, so we need to isolate it. So let's add 11 to both sides here. We eliminate the 11, and we get 4 times the absolute value of x minus 6 is greater than 16. 5 plus 11 is 16. Now we're going to divide by 4, reducing the 4, and we get the absolute value of x minus 6 is greater than 4 because 16 divided by 4 is 4. Now, my absolute value is isolated. I have a number on the other side, and this inequality is greater than. When my inequality is greater than, I have an or statement. So this is x minus 6 is greater than 4, or x minus 6 is less than, we switch it to less than, and we switch the 4 to a negative 4. So now we solve. So we're going to add 6 to both sides here, eliminating the 6, and we get x is greater than 10. Over here, same thing, add 6 to both sides, eliminating the 6, and we get x is less than 2. Negative 4 plus 6 is 2. And this is an or statement. Now that we have our numbers, we can draw a number line. On one side we have negative infinity, on the other side we have infinity. Somewhere in the middle is 0. Now, this is positive 10 and positive 2. Both of those numbers are on the right-hand side. 2 is a little bit closer to 0, so we're going to mark 2 right there, right by 0. And then we're going to mark 10 a little bit further away. Now, if I had greater than or equal to, or less than or equal to, if I'd had the or equal to part, the little line underneath, my points would be closed. I would bubble them in with a closed dot. But since I don't have that, I just have greater than and I have less than, then that means my points are open. So I'm going to put an open circle on both of them. And this is an or statement. In an or statement, you shade the outside. In an and statement, you shade the part in between. So we're going to shade the outside. And now we're going to write our interval notation. The beginning of the shading starts at negative infinity. So we're going to say parentheses, negative infinity, comma, and we shade until we get to 2. So we write 2. At 2, it's open. Since it's open, we use parentheses. If it were closed, we would use brackets, but it's open, so we use parentheses. Then we have a break. So we're going to say U for union, and then we're starting in at 10. 10 is open, so we're going to use parentheses, 10, comma, and then we shade until we get to infinity. And infinity is open, so we close with the parentheses. So if this had been closed, if it would have been bubbled in, then I would have had negative infinity, comma, 2 bracket, union bracket, 10, comma, infinity. This is when you have the greater than or equal to sign. On the 10, we would have had greater than or equal to. At the 2, we would have had less than or equal to. Okay? So we don't have that. So this is our solution. I just wanted to show you that if you did have that, you would use a bracket. Now, if I would have had a negative up here, that would have been negative 4, we would have had to decide, is it all real numbers or is it no solution? If it's greater than a negative, it would be all real numbers. If it would be less than a negative, it would have been no solution. So you need to check, is it a positive number or a negative number here? If it's a positive number, you're going to do what we just did. If it's a negative number, then you need to determine, is it all real numbers or no solution? So I hope you enjoyed me reviewing this week's material. If you have any questions regarding the quiz or the review that is in Schoology, feel free to send me a message or send me a text. Have a great day.